An introduction to Catalyst. We'll begin by showing a pre-packaged video on Catalyst, and then I'll give you my own interpretation. I can't begin to tell you how confusing I think that is compared to a simple model for catalysts. If I heard that right, they said that two catalysts combine. What is this? Two catalysts combine to form one catalyst? They also pointed out in the beginning that sometimes reactions in the gas phase don't occur, and so you can add a catalyst to get them to occur. Well, number one, catalysts can occur in any phase, right? You can use a catalyst for any kind of chemical reaction in principle. And number two, you can use a catalyst just to make a reaction go more efficiently. You can just simply add catalysts for a reaction that works anyhow, and you'll get a higher turnover rate, etc., etc. Here's my simple model of a catalyst. Suppose this is substance A and substance B, and you want to do a synthesis reaction to combine them. Wouldn't it be nice if you could provide a template, if you will, for them to go into these little pockets here, and when they do so, you're getting a lot of advantages. Think about it. We learned in collision theory that reactions have to occur at an active site, right? They have to collide at the right location, and if they can only fit in this orientation, it forces them into the correct orientation so that every collision, once it's inside the catalyst, is an effective collision. This can also lower the activation energy for the reaction so that they don't have to collide with as much energy. That's what catalysts do. They lower the activation energy. And finally, you can see how by this shape, I would believe that you could see how this thing can pop out and the catalyst can go over and do it again and again and again, so that the catalyst itself is not consumed. I think of a catalyst as a matchmaker. So let's review. It's a substance that speeds up the reaction without being consumed itself. This thing never gets reacted, so it is not a reactant. It is simply a catalyst. It provides a new pathway for the reaction with a lower activation energy. I don't know if that's completely true. I think it provides the correct pathway as the only desirable result. It forces it into the correct pathway. I'm not sure you can really call it a new pathway. And it acts as a matchmaker, which you can see here, providing a template for the reactants to combine at the right location. Yes, indeed. And it can be heterogeneous and homogeneous. Let me just describe that briefly. If it's heterogeneous, that means there's some kind of insoluble material, and oftentimes it's just a bed of palladium or something like that, that when the molecules hit it, that bed has the right sort of micro shapes within it, tiny little nooks and crannies, if you will, that provide this sort of template. If it's if it's homogeneous, then everything's happening in solution. This is dissolved, this is dissolved, this is dissolved, or perhaps everything's in the gas phase. In any case, it's all in the same phase, and off you go. This is catalyst.